Okay, next up in calculus, we're going to be dealing with the constant and the power rules. You need to be keeping these rules written down in the calculus toolbox and that dissimilar from the physics toolbox, because there's a lot of rules that you're going to be using. And one of the things that I will not be requiring is for you to memorize these, although many of these you're going to remember either because it's almost obvious, and the other is because you will probably be asked to know this later on in college, if you take college calculus. Right now, my goal is to get you familiar with these things, have them available for you to use when answering questions related to them. So keep all these together. Some of them are really important, and some are going to be used in proofs later on. The second point I want to bring up here is I am going to be giving you reasons why these rules work the way they do. This may not be the most exciting thing in calculus, but one of the things you need to get used to as a student is being able to prove where certain laws come from, what is the basis for it. And if you don't learn that, which is okay, I guess, but at least you have to understand that this is not something that was dreamed up and plopped on paper and say, okay, just use it. You got to have some depth to your knowledge. So a lot of proofs are going to be given to you, or a lot of reasons for why these rules work the way they do. The first one is an easy one, and that's called the constant rule. Now, what we're doing is we're looking at section 2.2 in your book. That's the second section of chapter 2, dealing with differentiation. This is one of those things that will seem obvious once you see the reason for it, but probably wasn't up to that point. And that is basically that if you have a function of x such that this equals a value of c, in other words, your y value is c for x, so we're looking at the ordered pair x, c, and you're asked to find the slope of that. So we're trying to find f sub x. Now, you have to remember that we've already defined the slope in terms of x's and c's and all that, and delta x's and all that. This is defined as the limit as delta x approaches 0. And this is where we use y2 minus y1 over x2 minus x1. So the y2 is your function of x plus, we could use c, or we could use delta x. Since we use delta x in the limit there, we're going to put that right there, minus y1, which would be your value of just whatever the function at delta x is, function at x is, over the change in x, which is delta x. So that's x2 minus x1 right there. So we've seen this before, like at least twice. But now I'm going to show you why the rule is what it is. And if we take a look at a horizontal line like so, going through the point on the y-axis at C, and we say that this is x right here. So this point right here on that line is the point xc. Okay? And let's also say that that this point right here for x is x plus delta x. And the value of that right here, as that hits that line right there, is again c. Only now the point is x plus delta x, comma, c. So this is your x1, this is your y1, this is your x2, and this is your y2. Okay, so if we plug in the values here, well, this is y2. We said y2 is equal to c. This is y1. That is right there. That function of x at that point is, again, c over, and this is the difference between these two, which gives us delta x right there. Well, this equals 0, or c minus c is 0, and so this is 0 over delta x, so this gives us a value of 0. That's our slope. Well, yeah, this is a horizontal line, and horizontal lines give us values of 0. But here's the thing. What that is telling us, that is when we start doing differentiation of a constant, okay, and the constant is whatever it is, k, c, 3, whatever, sorry, if the function of x is that, sorry. And that means then that the slope, which is designated as f prime of x, or y prime, or whatever, is going to be 0, because it's going to be the same value on that horizontal line. So if I ask for what is the slope for a function of x that equals 3, then the answer is 0. So if it's a constant, it's always going to be 0. So the constant rule states that if c is any constant, then f prime of c equals 0. Okay, we're going to see that from time to time in problems. The next one is the big one. That's called the power rule. And I'm going to show you how the power rule comes about by seeing a pattern develop on a number of these. We've done problems that showed the power rule, but we never pointed that out before. So let's take a look at f of x is equal to x cubed plus 3x plus 2. And let me find the derivative of that. So let's find f prime of x as delta x approaches 0. Now, in order to do that, we have to understand then that we're going to have f of x is this, and then that is y, that's your y1, I'll put a 1 there, subscript 1. And then y2 is going to be equal to, and you're going to replace every x after that with an x plus delta x. So using the definition of slope that we used up here, we're going to be using that. So f of x is going to be f of x plus delta x. So this is going to be x plus delta x cubed. This is not going to be a fraction. I'll move this up here. Plus 3 times x plus delta x plus 2. So when we find the slope of this is going to be y2 minus y1, so that's going to be x plus delta x cubed plus 3 times x plus delta x plus 2. That's your y2, put that red above it, minus y1, which is going to be x cubed plus 3x plus 2, and that'll be your y1, all over your change in x, which is x2 minus x1, better known as delta x. So we got a lot of mathematical manipulation to go through. This is a cube, so the coefficients are 1, 3, 3, and 1. So f prime of x as x approaches 0 is going to equal to, this becomes x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. So that's that part right there. Oh, and then my plus 2. I always forget that. Plus 2. Okay, so that's this part right here. And oh man, yeah, I forgot that part too, didn't I? So I need to put that in before I put the plus 2 in. So this has got to be multiplied out, plus 3x plus 3 delta x plus 2 minus, and I'll go ahead and subtract or change the signs of each of these, so minus x cubed minus 3x minus 2 all over delta x. Well, we can see right now that we're going to have things canceling out. The x cubed is going to cancel out the x cubed here, negative x cubed. The 3x is going to cancel out the negative 3x, and the positive 2 is going to cancel out the negative 2. So when the smoke clears, f prime of x as delta x approaches 0 is equal to 3x squared delta x plus 3x delta x squared plus delta x quantity cubed plus 3 delta x all over delta x. Now you can see we've got a delta x in each one of these terms, so we're going to go ahead and factor out a delta x out of each of those terms, and so that gives us delta x times 3x squared plus 3x delta x plus delta x quantity squared plus 3 over delta x. Now we can cancel out the delta x's right there. This now gives us f of x, f prime of x as delta x approaches 0 is equal to 3x squared plus 3x delta x plus delta x quantity squared plus 3. But now we factor this into the whole thing. Now that we've gotten rid of all of our denominators delta x, and we start plugging in zeros for each of these. So that becomes times 0. That becomes 0 squared. These all add up to 0, so basically that's out. And so the slope then becomes, as delta x approaches 0, the equation 3x squared plus 3.